We recently did a complete disassembly and some archaeology of a very rare Commodore PET in another video. Today we are going to build a diagnostic card and see if we can make it work. From the research I have done, I think this is one of the very first hand-built pre-production Commodores from 1977. So basically one of the very first personal computers ever made. Unfortunately, things went bad in this video, really bad. And something smells hot, but that could be normal. I will put a link below if you want to watch the disassembly and archaeology too after this video. Since the disassembly video, I have ordered some parts that I think we will need today. I have also cleaned and washed everything except for the tube. It actually came this clean, so it was clearly replaced shortly before the Commodore was put out of use. That is unfortunately not the only part that has been replaced, but all of that is in the linked video below. The only thing left to clean up is this nasty sticky goo. I can't say for sure what it is. Quite possibly a plasticizer that has come off from the cap here, or possibly all the electric grease. In any case, it has found its way down the tube here and dripped down on the motherboard, causing some corrosion. It looked pretty bad before the wash, but as you can see, this board cleaned up really nicely. There's just a tiny amount of corrosion on the solder on these two chips here. Not sure if you can even see it on camera, so I'll probably just leave it like this. Or perhaps I'll just reflow the solder on top of the PCB here. But definitely not a big issue. That nasty goo seems to be inside the cap too. So while we work on something else, I'm just gonna keep reapplying IPA on the cap here, and hopefully it will find its way inside and clean that cap. I wiped the goo off the tube and it came right off with just some IPA. So it seems to be easy to clean at least. Oh, I just noticed the rubber cap has actually gone completely hard. So that was probably most likely plasticizer, because this rubber cap is not soft anymore. Well, we may actually have to replace it, but that means ordering a new cap. So it will have to do at least for today, and we'll replace it in the future, whether it still works or not. Well, power would have been the first thing to check on a machine like this, of course. And in this case, it's kind of obvious that this PET has some kind of power issue. This pin here is completely charred, and the corresponding connector has seen some serious heat here. Okay, let's start by testing the transformer disconnected from the motherboard. But first, my usual disclaimer, please don't mess around in power supplies. We obviously have mains voltage present here. Okay, let's turn the power on. I've got the meter set to AC voltage. So let's start with these guys here. We've got 14.7 going to the CRT display. 14.9. Okay, now it raised to 15. Well, that's a bit low, but I think that's within specs. Then we've got these two guys here. We've got 15 volts AC on these two pins going to the motherboard. So the transformer seems okay. Okay, the next issue is that the rest of the power supply is actually installed on the motherboard. So that's a bit risky. However, I noticed that all the custom chips are installed in sockets. So we can actually lower the risk significantly by removing them, leaving only 74 logic on the motherboard, except for one 555 timer. And all the remaining chips on this motherboard are still available and can be replaced. I probably even have most of them in my stash. These crispy sockets here are unfortunately single wipe sockets. And I also noticed that they don't have a notch. So I think I'm gonna mark the notch, just to avoid making a mistake. The VRAM had some really funny looking sockets, and I actually think these are dual wipe. If I look down to these holes here, I can actually see that they make contact from two sides to the pin. I also found something weird on one of the RAM sockets here. This could be nothing, but I think it might be corrosion. I am obviously going to use deoxit on all the sockets, but that's for later. Next up we have the damaged connector on the motherboard. So I'll start by adding some fresh solder to make it easier to remove. I switched to my largest nozzle on the desoldering gun. No large ground planes to worry about here. That solder is coming out really easily. Yeah, that connector looks really crappy. Now, hopefully this was just caused by a bad connection. Yeah, something bad happened to this machine. I hope it's not too difficult to figure out what it was. I also noticed something weird here. There's actually some old solder on the pins here. Now that is really weird. So something has been soldered to this connector at some point. And I can't see why. This is really odd. I also noticed a small detail here that I missed in the disassembly video. Check out this spot here. Someone scraped something off here. Okay, this connector is going to be a bit trickier. But let's fix it anyways. I think there's a special tool to disassemble one of these. But this can be done with a screwdriver. So we just need to push this peg down. And then we can pull the wire out. And this wire here actually came off. Ah, of course, it's the burnt one that stayed in the connector. Okay, my replacement here actually looks identical to the original part. So this must be a really old standard. I don't have the crimping tool, so I'm going to add a splash of solder instead. I added some fresh solder to the cable too. Then I'm just going to reflow it. And then I think I need to bend these tabs and wrap them around the cable. Otherwise it may not fit inside the housing. Well, since they are identical, we'll just go ahead and reuse them. But we have to bend the locking pin back up before we install the cables in the housing. And here's our new housing. So ground in the middle, yeah, it looks nicely in place. And then we have these thick red wires connected to DC. And this cable just goes to that huge cap. And yeah, the new pin locks nicely in position too. And then we have these brown wires with incoming AC from the transformer. Yeah, I'd say this one is fixed now. I'll put that zip tie back on later when we know if it works. And here's our new connector for the motherboard. So now we can go ahead and solder the connector. But the question remains, why was there solder on the pins on the original connector? Did someone mess around and experiment with this board? I hope not. The custom chips on this board are not easy to find, so I really hope they're all good. All the logic chips are still available, and the 555 of course. The RAM and ROM can be replaced too. I'm gonna clean this flux up before we move on. As I mentioned, the board has already been washed, so that's all we need to clean, hopefully. Okay, let's reconnect the transformer to the motherboard with our brand new connector. Unfortunately, I should say. I would have preferred to reuse the original connector, but it was obviously unusable. Okay, so the power supply in this machine consists of three things. We've got the transformer that has been tested. Then we have this huge cap. And then we've got these 7805s. And there are 4 of these in a row inside these heat sinks. Okay, power on. Now let's see if this cable gets hot. No, it's not. So I'm guessing that burnt connector was probably caused by a bad connection. Let's start by checking AC on the connector here. We've got our 15 volts. I'll switch to DC. We'll check the DC voltage. 8.8 and 8.8, so that's a good start. Now let's see what's coming out of these 7805s. 4.9, 4.9, 4.9, and the last one off camera here is 5.0. Okay, that's great news. That means that this board at least hasn't been killed by overvoltage, like my good old Commodore 64 back in the 80s. Before we continue, we're actually going to do an upgrade to this machine. This may sound weird, but with this upgrade, we can test this machine without any ROMs or RAM. And that seems to be the 2 most common faults with these machines. And luckily there is a project to do this. and at the same time upgrade the RAM from 8K to 32K. To make this possible, I ordered some PCBs from the sponsor of this video, PCBWay, and I actually found this project on the shared projects page on PCBWay.com with some really good instructions. These boards can also be used in a VIC and a good old 1541. So this is a really cool project. First component we need is a 74-245. Most of the parts for this project are available at Mauser, and a couple of things I had to pick up at AliExpress. This chip has to be installed without the socket, because we're going to install a second chip on top of it. The next chip is a 74-157. And same thing with this guy. We need to install it directly on the PCB without the socket. I think I'm going to do all the soldering off camera. Not to bore you, but I'll go ahead and solder these two chips before I move on. And next we need some 100 nanofarad ceramic caps. And they are for C1, C2 and C3. We also have a resistor pack here. And this is the bus type. So it basically has 4.7K resistors, and they're all connected to pin 1. Next we need 2 rows of pin headers. And these have to be machine pin headers, otherwise you're going to crush the original socket on the motherboard. I'm going to solder the pin headers in a worn out old socket. This way they will be soldered nice and straight. Next up we have some SRAM. Minding the notch, it's gonna go in here. I'll start by just adding a tiny bit of solder on one of the pads. My solder is way too thick for this, but I ordered some more the other day, so we should be back to 0.38 in a couple of days. I aligned the chip off camera and soldered a couple of the pins. And next I'm going to use some flux. Some solder on the tip, then I'm going to drag solder the chip. So there seems to be some optional pads here for a dip package, but this is quicker than soldering a socket. The bridges are a bit stubborn today, so I went ahead and added some more flux. That tends to fix the problem very quickly, and it did. Okay, the next step is to install 40-pin sockets. Oh, actually I think we have a problem here. Yeah, this is not going to work, because the socket ends up on top of this row of pins here. So the socket is too close to this row. I can see why it's designed this way, because if it was installed further to this side here, there wouldn't be room for the logic chip inside. Okay, this is a problem. Well, not a big fan of machine sockets to use for ICs, but this could be our only option. We still need to cut this piece. So that didn't work too well. It damaged the socket. Okay, in that case, I'm gonna step outside and use the Dremel to remove these 2 bars. Okay, let's try that again. Yeah, now it fits. Machine sockets are a bit thinner, so now there is enough clearance to install the socket. I don't like installing ICs in machine sockets, because sometimes they don't make good contacts. But for this project we don't really have a choice until someone redesigns this board. Actually, we don't have a row of pins for this IC, so we can use a regular socket here. I almost forgot the 20-pin socket here. And then we have the dip switch, and it needs to be installed with the on position towards the resistor pack. It's kind of funny that the Commodore PET was aiming for the business market, and I think the Apple II was mostly aiming for the home market. But that kind of reversed. The Commodore was hugely successful on the home market with the Commodore 64, whereas I think the Apple II was a lot more successful on the business market. And the last thing we need to solder is a bodge wire to this pin here. And then it needs to go around to the other side and connect to this pin here if you're going to use this board with a Commodore PET. Don't bother cleaning up the flux because I'm going to wash this board after the video. Okay, let's add this guy here. Okay, I think we're done with all the soldering. Well, it's never a good practice to test two things at once. So I made a VIC version of this board and I somehow managed to find a working board in my stash. That took a while. I have two really nice VICs, but they are sort of too nice to mess around with. So I don't want to use them to do tests like this. So I guess I'll build something with this board and have sort of a lab machine. I think I have a really ugly case to go with this board. Wow, that socket is so crispy. Okay, finally got the 6502 out. We can now install our upgrade board and then install the CPU in the socket of the board. Oh, I see. So the CPU has been desoldered from the board. So some of the pins are bent. That also means the pins are a bit shorter and probably don't like that machine socket. But let's see if we're lucky. I have programmed these two chips to work in a VIC. I'm going to leave all the switches to off for this test. Okay, let's see if it works. Oh no, it doesn't. I've got a black screen. Oh crap. Oh, I just spent so much time troubleshooting that stupid board. Now it finally works. Wow, this VIC has some serious jail bars. You may not be able to see them on camera. We need to fix this VIC board in another video, but that's for some other day. So first I swapped the CPU with a known good chip, and then I swapped and reprogrammed the ROM. I didn't have any more surface mount RAM chips, but luckily these are plentiful if you have any 486 boards, because this is just a regular cache chip. It's a 51256 chip. They are much cheaper and easier to find on eBay than the surface mount component. I even swapped out that switch block. I also swapped and reprogrammed the GAL chip, but nothing helped. So then I went through all the files available for the projects and I found an alternative file to program the GAL, and apparently that was our issue. So now this board finally works. Okay, so next I'm going to turn the machine off and turn switch 2 on and turn the machine on again. Oh no, so the ROM still isn't working. Oh crap. Let's turn the machine off and set the third switch to on and turn the machine on again. Well, it works, but we still have 3.5K. Okay, so we need to set switch 4 to on 2 and turn the machine on. Okay, that's much better. So now we've got almost 12K of RAM. Let's turn that machine off and turn switch 5 to on. And now we've got 28K of RAM. Awesome. So for whatever reason, the ROM replacement doesn't work on this machine. Okay, I finally managed to make that ROM work too. That took a while to figure out. Apparently the bin file that was included in this project was not adjusted for this ROM. So I used this command here to double that file a few times until it reached 128K and then burned it to the ROM. And now it's working. I'll put a picture on the screen here how you need to set these switches. Okay, so now this board finally works. This video is probably going to be a bit short because I had to waste so much time troubleshooting this board. But now it's working. So next up I'm going to program a set of these two chips for the PET, because they are not identical to the VIC here. Okay, finally back at the PET. I took a picture of this board before I removed all the chips. And since all the sockets are missing the notch, I clearly marked them to avoid making any mistakes. So for the first test I'm going to skip all the RAM and all the ROMs. And I'm going to use deoxit in all the sockets. And these original sockets look pretty crappy actually. I hope they still make good contact with the chip. So first we have the PIA1 chip up in this socket here. And it's an MOS 6520. Good luck finding one of these if you have to. Up here we have the VRAM. These are a common issue, so let's hope these are okay. And these are MOS 6550s. And up here we have the PIA2 chip. It's identical to the PIA1 chip. And in this socket here we have the VIA chip. And it's an MOS 6522. And the last chip to go in is the video ROM. This chip is not replaced by our replacement board. Instead of the CPU, I'm going to install our project board. I have programmed these two chips for the PETs instead of the VIC. The procedure to program these is the same as I have done in many of my videos using the TL866. So that's why I didn't repeat myself in this video. I'm going to leave the ROM and the RAM on and turn everything else off. So no upgrades, just the 4K as it originally has, and presumably basic one in ROM. To test the board, we're gonna need a working display. So next I need to install the tube. Being extremely careful not to damage the neck. Since that tube is obviously pretty much unused. And yet the plasticizer has had some time to turn into goo, drip down on the motherboard and cause corrosion. I'm gonna say this machine has probably not been turned on since the 80s. Let's not forget this comb thingy, presumably grounding the conductive paint on the tube here to ground. And this is also where the ground cable connects to the PCB in the display. Well, I think I got most of that goo out from the inside of the cap too, but I think we have to replace it. Because not only has it gone all hard, it's also all blotchy, just looking really weird. I'm going to apply some fresh dielectric grease on the cap before I reinstall it on the tube. I decided not to wash this board because it has some paper labels with part numbers and dates. And this machine is sort of like a museum piece. So I think preserving it as original as possible is more important than having it perfectly clean. But I did wipe most of the dust off. Well, this project sure hasn't gone according to plan. But I'm an optimist, so I don't expect much of my plans anyways. But now we're finally ready to test the Commodore PET board with as few components as possible on the motherboard. So for the first time since probably the early 80s, let's flip that power on and see what happens. Oh, we've got something on the screen. But that doesn't look too good. But at least we've got video, although really messed up. Not sure what kind of adjustments this display has. Yeah, I think I can see some characters here. And something smells hot, but that could be normal. I'm gonna say that didn't go too well. That is a lot of smoke. Yeah, this project sure didn't go as planned. And here's what came out from the back. This isn't looking too good. And some more crap. And here's what blew up. Presumably a dried up cap. Well, if you came for the magic smoke, you got plenty. Did I curse? I probably did. Wow, that explosion was massive. It even made a dent in my bloody wall. Okay, let's inspect the damage. Wow, that cap is a goner. What the heck? Why did it blow up? Well, luckily I can't see any other damage. Well, except for the cap, of course. But the question is, why the heck did it blow up? We checked the voltages, and they were good. They were actually slightly on the low side, but within specs. So did this thing just blow up because it had dried up? I never had this happen before. And all these connectors are keyed, so they can't be installed incorrectly. I got some more crap here. Well, I'm glad nothing else is damaged. So, I guess I'll order some caps. Well, I like to keep this project as original as possible, but I can't blow stuff up, so I'm gonna go ahead and replace all the caps. Even with a museum piece like this, I still want to have it working. Well, I'll order some caps and we'll have a second go. If you found this video interesting, consider watching this video next. If you have already watched it, hit the bell icon below and set it to all to get a notification from YouTube when the next video is out. I will end by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you like this video, let me know with a thumbs up in the comments. If you're a regular viewer, consider subscribing to this channel. Thank you for watching. I'll see you next week.